So somebody made the mistake of asking us to cover sea breezes, and I think what I would say is be careful what you wish for, because it's a reasonably complicated subject. I've tried to distill it as best I can. What I think I said in the ad for this evening is a lot of this is taster for a bigger topic, and this is definitely one of those. We'll introduce you to it. I'll show you where to get more information if you're keen, and show you what you need to know for Lymington to get by. It's one of those, if you want to go into it in much more detail, please do. It might help you general sailing wherever you go in the world. If you're just sailing at Lymington in club races or training out of here, then the basic rules of thumb will see you through. Okay. Can we see the picture okay?
Yep.
Yeah, it's better.
Thank you.
Echo's gone too.
Yeah. Okay. Yep. I think somebody switched the sound off there. Yeah. So what I'm saying here is it's a nice picture, midsummer, sea breeze, light and fluffy clouds, and then just the southwesterly breeze here we've got in the Western Solent. Okay. So sea breeze, focus in the Solent because that's where we sail, but we can, the generics I give you in this will cover you for wherever you sail in the world, really. First thing I need to do is put some theory up front. And we're going to talk about a wind quadrant tool and what exactly gradient wind is. Then we're going to ask what is a sea breeze, a genuine sea breeze, a true one, not what the commentators think is in the America's Cup in New Zealand. That was thermal enhancement, if you're interested. What factors influence sea breeze generation and what to look out for at Lymington. Okay. So let's go for it. Wind quadrants. Okay. So what I want to do here is just position this as a tool that we use whenever we're talking about thermally affected winds. Okay. And what we do is we line this tool up to the coast. So put the long green edge, which is the land, we put this tool up against the coast. So on the south coast, this would pretty much be orientated as it sits there. Yeah. So quadrant 1 would blow out the northwest, quadrant 2 would blow out the northeast, quadrant 3 the southwest, and quadrant 4 the southeast. Okay. And it's really helpful to use this quadrant tool because the thermally affected wind is really important how the gradient wind, the wind that's coming out the quadrants, aligns with the coastline. Okay. And we'll develop that a little bit more here. I won't go too far into that, but it's just, as I say, whenever we're talking about thermally affected winds, we're interested in where the gradient breeze is coming out of the coastline or onto the coastline. That's that piece. So we talk about quadrant 1, 2, 3, and 4. 1 and 2 are off the land, 3 and 4 are off the sea. Okay, so what does that really look like when we apply it? What I'm going to show you now is how we use the wind quadrant tool in practice. What we've done is we've put up a map of the south of the UK and the French coast. And what I've done is put some red arrows on, which shows the gradient wind flowing clockwise around a high pressure system. And then we've identified 4 locations, A, B, C, and D, and we've put the quadrant tool up against the coastline for each of those locations. So at quadrant A on the east coast, at location A on the east coast, we have lined up the quadrant tool and we've idealized the coast as sort of facing due east. So we've run the quadrant tool here north-south. So remember, we take the long green line and face that up against the sort of direction of the coast. Same at B on the French coast. It's a bit more obvious here. The French coast runs north-south there, so the quadrant tool lines up nicely there. This time it's facing the other way around because obviously the coast is the opposite direction. C, where we live, we're idealizing the south coast as running east-west. So as such, we've got the tool orientated that way around. And finally, on the North Devon coast, that is running northeast to southwest, and we've lined the tool up, again, long green edge, facing the direction of the coast. So the question is, what quadrant number is that gradient breeze blowing into at each of these different locations? So at location A, we've got this northeasterly. It's blowing onshore and it's coming out of quadrant 4. At location B, still the same northeasterly, but this time it's blowing offshore and it's blowing into quadrant 1. The arrow's lining up the same direction as quadrant 1. Where we are, we've got more of an east-southeasterly, so it's sort of cross-onshore breeze, and as such, that's coming into quadrant 4. We describe that as a quadrant 4 breeze. Finally, at location D in North Devon, you've got a straight offshore breeze, and that blows into our quadrant box as a quadrant 2 breeze. Okay, so now let's have a look at what a gradient breeze is. A gradient breeze is actually a theoretical breeze, but you can say it roughly equates to what the breeze is doing at about 500 meters above sea level. And it's the breeze that follows the isobars effectively. Okay, so in a low pressure, we talk about it going round in a anti-clockwise direction, and a high would go around clockwise in the northern hemisphere. So that's what we're talking about, pressure gradient wind. We're talking effectively talking about the wind at about 500 meters and above. Okay. I just want to put that in to clarify. Right, so let's get down to it with those tools in mind. Would anyone like to offer up what they think a sea breeze is? Or how it's caused?
Is it the warmth of the land causing the air to rise due to it being warm?
Yeah, that's 50% of it. Yeah, exactly right. Then how does the actual sea breeze mechanism generate?
Well, it pulls in off the sea.
When nothing is pulled, it's pushed. So the air fills in to fill the vacuum created by the lifting.
Right, okay, we're most of the way right with all of that. Let's put a definition down, I think, just to clarify it. Can you see that diagram okay? So Wayne quite correctly said that the air of the land is warmed and expands. Nick correctly said that the breeze comes in onto the shore. Whether it's a pull or a push, that's up to you to decide. I think a push is probably good, or a pull. It could be either. There's certainly a current that's flowing around here. So what happens is the air rises. We need a little bit of, in this diagram, a bit of right to left gradient breeze, so up at 500 meters and above, to push that warmer air outwards over the sea. The sea's a bit colder, so it makes the air sink. Gravity sinks the air. That colder air is a bit denser, so it's heavier, sinks back in, subsides over the sea, and then, as Richard says, that pressure difference, the low that's created on the land and the high that's out to sea, the high wants to meet the low, so it pushes across. So it's a circulation. We call it, so the way that David Houghton explains it in the Bible, wind strategy, is the wind which blows on shore when the warming of the land by the sun generates a closed circulation. So that's this loop I'm talking about here. Let me highlight that for you. It's think of it as a circulation. Yeah, it's going out, round, and like that, and in. Okay. Closed circulation, the offshore breeze near the surface being supplied by air moving offshore in the same general area but higher up. So you've got like a reverse flow out here, a return flow they call it, and the sea breeze coming in. Okay, are we all happy with that? I think you've got the sort of general concept as the warm air, the sun warms the land, pushes it up. The sea doesn't warm at the same rate as the land because there's a lot more thermal inertia in the sea. It takes longer to warm up. It's blown across, condenses or sinks, and then gets pulled back in. Okay, so that's our sea breeze cycle. It's also known, and I'll refer to this from now on, the closed circulation is known as a sea breeze cell. okay? And the strength of that circulation affects the maximum wind speed that we'll get. And the wind speed is always maximum nearest the coast, sea breeze. And it also affects how far out to sea that sea breeze will extend, and in fact, how far inland. Okay, any questions about that sort of fundamental? We're all comfortable with that? I think.
Karl, can I just ask?
Yeah.
In terms of that sea breeze, is that kind of if you're looking along the land, is that 500 meters? Is it a mile? Is it 2 miles? Is it kind of?
Yeah, how far out does it extend? That really depends on the strength of that cell, how far this cell can rise up.
Yeah.
Okay, and how much gradient breeze there is, and what the temperature differential is between the air over the land and the water. Okay, so there's quite a lot of factors into how far that might extend. So if we assume that it's going to be, yes, at least a couple of kilometers, but it can be way more if it's a really strong one. And it can extend quite a way inland as well, some 20, 30 miles at least.
Okay.
Good question. But the answer is, it depends. Right, okay. So I think I've already mentioned some of these, but let's see how well you were listening. What factors do we think influence sea breeze generation? Sorry, say again?
Heat of the sun.
Yeah, how much heat there is over the land, yeah.
Temperature of the water.
Temperature of the water is important, yeah. Anything else? Somebody else said something, I missed it. Something about wind.
Wow. The strength of the gradient wind.
Yes, perfect, thank you. Anything else to do with that?
Just
Gradient wind, if you've got strength, you've also got what?
Direction.
Direction of the gradient wind, yeah, that's just as important, probably more important, yeah. Anything else? This one's a bit esoteric, but we talked about how deep that cell could form. What do you think would stop that forming? It's something we touched on last week when we were looking at sounding charts and meteor airgrams and things.
Is it the mixing?
Yeah, it's the mixing and whether you've got a temperature inversion or not that'll cap it. So I'll go through all these in a bit more detail for you to fully explain them all. So we said the air temperature of the land and the sea temperature. So we need generally accepted minimum is between 2 and 4. The more you get, the better it will be, the stronger it will be. The size and the topology of the land mass that the warm air is rising above, and I'll show you that in a bit more detail in a minute. And I think to give you some relatives on that, England is a sizable landmass. The Isle of Wight is not, and Cornwall is not, nor is Auckland, New Zealand, where that's sited. Those are not sizable land masses. They're quite skinny, and that has a bearing, which I'll demonstrate to you in a minute why. The gradient wind direction speed we mentioned, because we need that gradient wind to kick the cell off to make it start circulating and to sustain the circulation. Needs to be offshore in quadrant 1 or 2. So we've already met quadrants early on, and not too strong. That's the gradient breeze. If it's too strong, it can oppose this flow back in, okay? When I say too strong, if it's coming, if there's a lot of mixing and it's coming low and it's stopping this flow back in, okay? And I'll show you that as well. And then the stability of the air mass we just touched on, which is if there's a temperature inversion found at low level, it'll cap that sea breeze cell. So one of the things to think about here is that the sea breeze, this cell could be something like, oh God, my writing's hopeless. Something like a kilometre high, 1,000 metres deep. If you get a temperature inversion at sort of 100 or 300 metres above the ground here, and it's capping that circulation, you can see that it's not really reaching the full gradient breeze, which sits at about 500. So you're not getting that much return. The return flow here, the gradient breeze will be quite light, and it's also just doesn't get very high. So that circulation will be so much less if it's capped by that temperature inversion. Okay, again, I'll show you that in how we detect that in a minute. Any questions on that so far? I'll go through each of these four in turn and show you. Okay, so difference between land and sea temperature. That's the one everyone thinks about when you think about sea breeze, and that is really, really important. What I've done here is in one of my case studies last summer, I've just taken a few snapshots of what I found. On the 7th of June, which was a Sunday, there was a weak northwesterly gradient in the morning. This is at Lymington, by the way. So northwesterly gradient is already, in my mind, that's coming out of quadrant 1. That's a good sea breeze direction quadrant, or sorry, good gradient breeze direction quadrant. And there was a water temperature of 15 degrees measured at the Bramble Bank post, which is the only place I can think of that's a water temperature thermometer around here, unless anyone knows different. And an air temperature over the land, and I measured that at Southampton Airport because it's somewhere inland of the Bramble, of 18, 19 degrees. And that would be indicative of the same sort of air temperature we get over the forest. Maybe it might be slightly warmer over the forest. And that was enough to generate that circulation we talked about and give a decent sea breeze in the Western Solent. And the way we can tell that is looking at the wind on the platform. You can see here at sort of 8 in the morning, we've got a gradient northwesterly, yeah, and it starts to flick around sort of north-ish, and then about, it's just coming in here 10, so 10:30, it settles into a southwesterly, and southwesterly is a really good sea breeze direction where we live. So that to me is sea breeze, and you can see in the wind strength, which is indicated here, we get that same change. Okay, so this was a sea breeze day. It was an early sea breeze day, but we're in June when the relative sea temperature is quite cold. It hasn't peaked yet. It'll peak in mid-August, maybe around 18, 19 degrees. But at this time of year, it's quite easy to kick off a sea breeze. You can see on that temperature chart at the airport, you've got 18, 19 degrees, as I said, and then that gradient at the airport as well was kind of northerly, northwesterly, just at the right time for us. Well, that's still inshore, it's still northerly, which is fine. You quite often find that. So this sea breeze isn't necessarily penetrating that far in at this stage, certainly not up the Solent, up Southampton water, but certainly where we were, it would have been. You'd have felt that in Brockenhurst and north of that. So that's showing you the difference between the land and sea and how that can kick it off. So that's a dead important factor. So we said 2 to 4 degrees minimum delta between land and sea. More the better. Be careful when you look at the Bramble Post here, there is a red line, which is the air temperature. That's the air temperature of the water. We're not really interested in the air temperature of the water. We're interested in the air temperature of the land, because that is the air that's rising, coming out over the water and then subsiding. And it's that that makes the difference. We're not worried about air rising off the water. It's not going to have the same effect, because here you can see actually, probably because of the wind blowing, the actual air temperature on Bramble Post is lower than the water. It's not really, so don't get caught into looking at that. You're much better off. That's why a lot of the navigators and sort of Met specialists on boats are always looking at the airports. You're looking for somewhere inland a little bit, and that'll give you an indication of what's happening behind the coast, which is so important for the sea breeze source. Is that clear to everyone? Any questions on that? I mean, this is the fundamental point. Okay, everything else to this is sort of supplementary, but is a factor in what builds a sea breeze. So the next thing I talked about was the size of the landmass. And if we take the Isle of Wight as a really good example, in the absence of any breeze anywhere else, let's assume that the Isle of Wight heats up and we get a bit of circulation going around the coast, so it's blowing inwards to the coast. What actually happens in that case is that inward sea breeze cools the land too much and switches off the heat source. So it goes quiet, then the land heats up again, circulation starts, and then it switches off again. Same down in Cornwall. There's not really enough meat of land here to give us a really good heat source. And when it does warm up, it'll cool down again quite quickly. So if we think about sort of south coast of England, there's much more backing land behind that. to really properly generate that sea breeze. So if you think it's warm up in the forest, Salisbury Plain, all these places, that's going to create a super duper sea breeze down through the Solent, Christchurch, Lyme Bay, everything else. Okay, so that's the piece about the size of the landmass. So gradient wind direction, this is a real key piece as well, because this is what helps that circulation, initiate the circulation. So my question to you from here is, having seen that quadrant diagram before, and all other factors being equal, all the other sort of things that we need for ignition on a sea breeze are in place, which quadrant or quadrant does the gradient wind need to blow from for a sea breeze to be able to form, and why?
One and two, didn't you say?
Yeah, 1 and 2, perfect. It's got to be offshore, hasn't it?
It's going to be offshore, yes.
Yeah, yeah. If it's blowing onshore, it gives us a different effect. It gives us something called thermal enhancement or thermal disenchantment, which I'm not going to cover tonight. It's definitely a thermal effect, but for true sea breezes, where we're going to get the maximum punch, it's quadrant 1 and 2. Okay, so the reason for that is, for a true sea breeze, and I'm very particular about this word true sea breeze, we need an offshore gradient wind to promote that circulation and that subsidence over the water. Yeah, that's that cooler air falling and creating the high pressure on the water to the low pressure on the shore, and high wants to flow to low, remember. Okay, second part. Just assume that I'm right about this, that a quadrant 1 gradient is preferable to a quadrant 2. So we've said it has to be offshore, but there's offshore and there's offshore. Quadrant 1 is the favorable offshore that we want. If you imagine the south coast as a straight line along the Solent, you know, out towards Christchurch and beyond, out towards Portsmouth and Chichester, which direction is quadrant 1? What would the compass direction of the gradient wind on the compass need to be to give you a quadrant 1 gradient breeze?
Southeast.
Get round to 3 and 1 from this.
So again, imagine the land. Imagine the south coast is my red line doing that,
Yeah.
and I want a gradient breeze that is going to kickstart a sea breeze, the strongest one, a quadrant 1 sea breeze. What is the angle on the compass of quadrant 1 to our shoreline?
4, 5.
Say again.
Oh, 3. So, yeah.
No, I'm talking about angle on the compass. Like, is it northeast? Is it southeast?
Southwesterly.
Southeast.
NW. So
Yeah, it's so we're talking about this quadrant here. The land is that red line across the top. So where we live, north will be upwards, won't it? So this one here is northwesterly.
Yeah.
It's coming from the northwest. Remember, when it comes from, yeah, it blows from and to. I know it. Sorry, it blows from. Tide flows to, and wind blows from. Confusingly, so it's a northwesterly. So on our shoreline, we are looking ideally for a northwesterly gradient to give us a strong southwesterly sea breeze in the afternoon. It can come out of quadrant 2, and I'll explain that a bit later. Okay, so the answer was northwest on that. Are we all comfortable with that? This is at Leamington, so we're assuming that the coast is a straight line, north pointing upwards. We want a quadrant 1 gradient breeze first thing in the morning. That has to come out the northwest. Okay. Right. So this is what it looks like in practice. If we start the morning here with our northwesterly gradient wind here, and then as the day progresses, if the sea breeze generates, it'll first start here on the south, on this line here. Sea breeze will start from sort of true southwesterly, and as the afternoon works on, it will clock round, it will veer, or you'll hear some sailors call that going right. Okay, so by the evening, that wind will end up crossing the shore sort of parallel. You know, if you imagine the south coast going along as a proper line, it will end up crossing the line sort of in parallel of that before it switches off and goes back to gradient. Okay, so we're looking for a southwesterly here, which will generally clock late afternoon. So by the evening, when we come to evening race, you might find at 5 o'clock, we've still got stacks of breeze as you're rigging your boat. You start at 6:30 in a bit of breeze, and then come 7:30, it's switched off or it's clocked all the way back around. And that's typically the sort of end of a sea breeze day. That's really common on our Wednesday night racing. We see that a lot. Okay, any questions on that? That's sort of putting it into the theory into practice, if you like, what it would look like. So that northwesterly that we're looking for will give us a southwesterly afternoon sea breeze, assuming everything else is right, the temperature differences, the air stability and everything else. Okay.
Can I ask a question?
Yeah, of course. Yeah, please.
It's a stupid one, this, because I was
No, stupid.
I was thinking that was going to come southeasterly because of the northwesterly wind coming in. Why is it? Just tell me what I am.
Well, I thought as well, yeah, but
I'd agree to being. I'd have assumed it was in the opposite direction.
Right. Okay. So you're right to a point. What it does very initially out to sea is it will start opposing it to a point. Okay. And then it swings around very quickly. Definitely swings around very quickly to that southwest. And then keeps tracking round. It's very unsteady initially, so it doesn't take long for that swing to occur. And in fact, I've got an example, I think, on the end of this, where the sea breeze we had this morning in Auckland for the final of the America's Cup, I tracked that, and that's showing exactly that, where it starts up in kind of almost the opposite-ish, and then swings very quickly back in and settles in this sort of southwesterly and wants to work backwards to where it came from, if you like. Okay.
I'm still confused by that bit, to be honest, Karl. So I won't.
I'll refer you to some reading for that.
Okay, thanks.
That helps. The Bible, chapter, wherever I lifted this from, chapter 8, the Bible, wind strategy. That's referenced on our weather and tide section.
Did you get that from the community centre?
I get that from the community centre. It's funny because it looks like Nick Rogers, but he's selling a fin, so it can't be Nick Rogers. Okay. I'm not sure who it is. It's got the same determined look. Yeah, okay. All right. So the other thing is, and I've put the answer here already, but no one, we talked about this already, is the gradient wind speed. Why do we think a strong gradient wind speed blowing out of offshore might limit the formation of a sea breeze cell? I think I sort of suggested that earlier, that it stops the return breeze coming back in. It'll be in total conflict. And the sort of perceived wisdom is that in the Solent, anything over 20 knots is going to highly reduce the likelihood of a sea breeze. Okay. Right. This was the piece I talked about with the inversion layer. And I sort of covered that in that drawing where we talk about stability, which is how much the air will mix or not mix from lower levels up to higher levels, you know, sort of beyond 500 meters where the sort of gradient wind is and above. Typically, as you go up in altitude, the wind becomes less and less affected by the surface friction of the earth, and in theory gets quicker, okay, to a point. If there is any limit on getting up to that quicker air due to a temperature inversion, you won't get as much gradient wind pushing that breeze offshore, okay? And a temperature inversion is identified by, if you took a packet of air on the ground, and as it goes up, it will tend to cool. But at a temperature inversion, what will happen is it'll start to warm up again. And what that will do is effectively pull a cap over, let's say somewhere between 100 or 300 meters perhaps. And our air won't be able to rise anymore. It'll just have to go out to see if it can with whatever breeze there is at that sort of 300 meter layer. So if there's no breeze there or it's very light, the cell is going to be exceptionally weak, okay? Now, the way you can tell if you've got this temperature inversion, I think I mentioned this before, over the Solent, viewed from a distance, you see a sort of yellowy smog, the pollution sort of captured at a low level. You can see it if you've got any smokestacks and things, they'll go up and they'll be capped at a certain level. They won't go up, you know, they won't keep going up, up, up. They'll sort of seem to sort of blow across a little bit at a low level. So that will give you a clue that the air is very stable. And the other thing with stable air is that the air is quite hazy. So if you can see the Spinnaker Tower normally from where we live, it's normally unstable air. It's very clear. Whereas if it's stable, you tend to get a bit of sort of light refraction and things. And you get that sort of haziness where you just don't really see things so clearly in the distance. So that's a good clue as to what's going on with that. Again, this was the fourth of our factors of what contributed to the generation of sea breeze. Could sea breeze form? Okay. Right, and the air stability we say we get from the sounding charts on windy is how I do it, or those techniques I've just shown you there about looking at the sky and stuff. So on this left one, this is an unstable chart where you can see the breeze up at 1,000, 1,500 meters. It's kind of 30 knots, and down on the ground it's at 20. So there hasn't been much slowing in the atmosphere. And this is without gusts. This is just gradient. This is you know, mean wind speed. It's being pulled down. So this will be a gusty day. And the way I think of that is when you look at the red ones, the air temperature, blue ones, the dew points. If you can see a clear channel between those going all the way up, I think of that as a real clear passage for the wind to go up and mix. It can get up and down really quickly. If you look on the right one, we've got a pinch point in those two. So that's showing a low cloud base. And you can see here, the wind at ground level is actually 0. So on these barbs, a dot and a circle around it means no wind. And then it's very light, 5 knots, 5 knots, 5 knots. And it's not until we get up to 4,500 meters where there's another mini sort of inversion gone on. Something's happened here. You're getting into 20, 30 knots. So that's a very sort of, sorry, I beg your pardon. It's a very typical day of sort of anticyclone, slow air, not much going on, and that low capping. So you can see here that capping's happening, you know, less than 1,000 meters with no still air. So there's definitely not a sea breeze day going to happen on that. You just haven't got the circulation. Okay. So remember, we get these from, I've been using these from Windy. We just do the right click on that and see what the sounding forecast is. So that's the sounding forecast, remember, is the air temperature measured up with altitude for a given point in time and a given point in space. Okay, what to look out for at Lymington? So these are probably the key things you need to worry about. You know, the rest, everything else is theory. These are the things we need to sort of put in our locker and remember. So significant sea breezes tend to form in the afternoon during late spring and summer, assuming all our conditions are right. Although during extended warm weather, they can come earlier in the day. So that 7th of June example I showed you was at 10:30 when it came in. I've said during late spring and summer, they can happen earlier. Talking to Hannah Snellgrove this morning, she thought she'd seen some action in Portland Harbour already this year. Not for very long, but there's definitely thermal effect, she said. So it is possible. I almost thought it was going to happen today, but it just didn't get warm enough. It cleared up, but just never quite got warm enough in time for it to happen. Everything else was in place with the northwesterly, nice mixed air, everything else, but it just clouded and just wouldn't let us. The other thing we want is that northwesterly quadrant 1 breeze. And we're likely to be in a high pressure system to get that, because that's, you know, when the high pressure sits over us, we tend to get the northwesterly, depending on where the high pressure's sat. A warm day with not too much cloud cover early on, because we want that land to heat up as we've identified. And what you're looking for is initially low, patchy or thin clouds moving offshore. Now, you're probably better viewed to see this sort of still on Milford Cliffs, really, more than in the Solent, moving out and dissolving. And then usually cumulus clouds will form over the land. Now, sometimes they might not if the air is really dry. You can still get the sea breeze effect going on. You just won't necessarily get a telltale of the cumulus clouds, but more often than not, you'll get some cumulus to show you over the land. Okay, What the other telltale is, again, if you stood on Milford Cliffs for this, is that you'll see the wind going light. If you're looking down on it, you would see the wind going light on the shore and going calm before it changes direction, and you'll see a line coming in from afar. If you're on the Solent where we sail, what you'll see is it'll go really, you might have been sailing along in a nice northwesterly, then you get a shutdown maybe for half an hour or so, or it keeps trying to sort of goes and comes, then goes finally. And then what you'll see in the distance, if you look through Hurst, you'll see a black line approaching, and you'll see the boats that were heading out of Hurst suddenly heeled over and beating. And as the sea breeze works towards us, like I said, it's initially very unsteady offshore. You know, like you say, it's opposing the land direction, but then it swings around pretty quickly and stabilizes into this southwesterly. Okay. And what you get with a sea breeze is it becomes quite a steady breeze with what we call long phase shifts. So it's oscillating backwards and forwards, but over a period of a few minutes, and then it's tending to the right as it does it over the day, over 3 or 4 hours. Southeasterly sea breeze is a bit of a disaster zone for us. So anything in the northeast in the morning as a gradient will tend to indicate a southeasterly sea breeze. And the problem with the southeasterly is it's never as strong anyway, but also it's got the Isle of Wight to contend with. It turns it into an offshore breeze where we live. If you think about the way the coast angles, it makes the Isle of Wight tends to block it quite a lot. So what you can find in Lymington is no breeze at all, but actually down at Leon Solent, you might have 12, 15 knots where they're sat in a beautiful southeaster. Okay. Any observations from any other Lymington experts? You've sat here a long time, Richard.
Sorry, no, it took me a while to unmute that. No, not specifically. I think you got the salient points. As you say, I think the big misunderstanding is often between true sea breeze and thermal enhancement, whereby you had a bit and now you've got a lot more. A lot of folks miss that.
Yeah, so that tends to be more of an onshore gradient breeze effect, which we can cover another time if you want, or it's definitely covered in the book.
No, it's another day, but
yeah,
it's,
yeah, that's absolutely right. It's because they were, like I said, they were mistaking it on the New Zealand, on the America's Cup this week. They're talking about it on Monday, and when I look back on it all, it absolutely was not sea breeze.
No. So they're very different modes of action.
Yeah.
And you know, you can get caught out very quickly by thinking one is the other. But yeah, apart from that, you know, yeah, you've got it nailed. It's cool.
Cool. All right. Okay. So do you want to look at the America's Cup first? Should we do that in case we don't get time to do anything else? What it turns out is if you're in New Zealand and you're a sailor, you're not quite as blessed with the weather resources that we are. It was very difficult to find the information I needed to complete this, but we got there eventually. And there's one thing I have to qualify first of all, is my quadrant is definitely correct in this one, okay? Because in the Southern Hemisphere, this mirrors, okay? Quadrant 1's on the other side to quadrant 2, quadrant 3's on the other side of quadrant 4. So I've probably totally confused you with all this by now, but certainly that's the tool we're going to use in that way round. Okay, it's because of the way the winds go around in the Southern Hemisphere. That's what makes it different. They go around the highs and the lows the opposite way they do here. So we're in Auckland for the America's Cup, up the top left there of New Zealand. This is a map of Auckland and the area. They were sailing this morning on course A. Sorry, I'm giving it away with that. Hang on. Course A. And they were sat in close. They set the course A as southerly as they could to get a squeeze off Rangitoto Island. So Rangitoto Island's that big volcano you could see, the extinct volcano. You see in the pictures. So that was up the right-hand side of their course. And they're using that because they wanted some compression off that island to give a bit more breeze in here. And the sea breeze did settle in at northeasterly, but at 7 to 11 knots. So that was the course alignment. There's the sea breeze. So the required gradient for that out of a quadrant 1 is something out of the west. So if you think how Auckland Harbour is, it sort of slants, doesn't it? It sort of goes up northwesterly, southeasterly. So when you align the tool up, that tells us we want something out of the west for a gradient in the morning. But my question to you is, based on one of the things we looked at earlier, why do you think the sea breezes are quite light? And I think there's 2 clues for you. One's the geography and the other is the date.
Not the landmass, no.
Yeah, absolutely. Yeah, landmass is really, it's just not much there, is there? Just not much there at all. So you're absolutely
It's
right.
basically an isthmus.
Yeah, it is. Yeah.
Yeah.
So it's like Cornwall. Yeah. So
Is the water still quite warm?
the water's very warm, and it's when I checked it, it was 21 degrees out in this area. Certainly at one of the weather stations out here. So it's pretty warm. Yeah. What do we think about the time of year? Is that height of summer? Is it spring, autumn, southern hemisphere?
Autumn.
Yeah, it's autumn, isn't it? So sea breezes are going to tend to be a little bit weaker anyway. So yeah, I think you picked up on those. That's quite good factors. So just to show you that gradient breeze coming in, and sorry if this is too confusing, but I thought it was pertinent just off to today's racing. I had to go out and find an airport that had the wind direction in the way I wanted it. So, this is north of Auckland. And what you need to know is on here, the wind speeds are actually in kilometers an hour because they're Kiwis, and this is sort of a land-based Met service. And I couldn't find a way to change it into knots. So a real rough guide is just divide it in 2 for knots. Okay, so what you can see is through the morning, they're getting something out the west, which is key. Yeah, remember we said we wanted that westerly gradient because of our quadrant box. Yeah. So as we line that up to the shore, we want something out of the west to give us an afternoon sea breeze, which is what happened. And then you can see as the day goes on, it sort of flops sort of to the south and comes into the east, opposes it a little bit, tries to come in, flops back. So this opposing it directly on shore, which is a question you're asking, Tony. Why has it gone round? But the answer is it is there initially, and then it tries to stabilize round. It tries to come round to settle. And this is what it's doing here. It's doing an oscillation, east, northeast, southeast. Then it finally sets in for the whole afternoon, and quite late on, actually, if you look at that, before going back. And it sits in there. They're recording as 12 knots inland at northeasterly. So actually where they are, they're affected by sea breeze as well. So there's indication of gradient in the morning and in the upper air, sort of, at 1,000 meters or so, that they had the westerly they needed. It's not super strong, but it's enough to kick it off and get that sea breeze in that they wanted. Does that help? Were you all right with that? I know it's not the Western Solent, but I thought it was fun because it was applying it in practice to something we could see that really happened in front of us this morning. And the racing got so boring. I was watching this with Hannah and Pete Barton, and I was just busy looking at the clouds. And there was a haze over Auckland, which was interesting. So, but the clouds, the nice fluffy clouds further off up the shoreline. So I wondered if there was a temperature inversion there. There might have been one, but it might have been high enough up to make everything happen okay, because that sea breeze sustained all right today. Okay. Couple of quick other slides. I've just got 2 questions on these. This is one of those sounding charts again. Remember, we've got a wind speed up the side here, which is that purple arrow with altitudes, and we've got the wind direction here. Then we've got the sounding chart, which is the red line is the air temperature, blue is the dew point. And my question to you is at 3 o'clock in the afternoon, remember this is a forecast, this diagram, is there a sea breeze predicted? Yes or no? Think about where the winds come. This is at Lymington. Sorry, we've gone back into the Northern Hemisphere in Lymington very quickly there. So what's the wind doing at sea level? This is mid-afternoon, so this is what they think the wind's going to be doing. It's blowing a southwesterly at sea level, okay? And then as we go up in atmosphere, that's their forecast. And as we go up, they're talking about a northwesterly,
So,
right in the zone that we need it, 1,000, 1,500 meters to get that circulation. Sorry, that's gone the other way. So yes, it is a sea breeze day, and there is a sea breeze predicted. What features do we notice? It's reasonably unstable, actually, because we're getting the wind speed here. Well, sorry, no, it's reasonably stable. Sorry, it's an 8 knot line there of breeze, and that 8 knots goes up quite a way. And you can see we've got that temperature inversion there, which is capping it at 1,700 meters. So our sea breeze sail rises, you know, 1,000, 1,500, 1,700. So it's probably just at the upper end of limiting it, but it still looks like quite a decent sea breeze at 8 knots. That's okay. It's nice. And you can see it, sort of the wind shearing as you go up there. Okay, so the features to look for are the wind here, southwest on the sea level, northwest at gradient height, and then that sort of temperature version is probably right on the limit where it matters. Okay,
It's quite useful for the guys to find somewhere to get that information, Carl.
Yep, so this is all on Weather and Tides, and I've written an article on how you read these.
Cool.
Okay, because I know it's quite technical. I get that, and how you install it, and how you all the rest of it.
Yeah.
What's the green line showing us? Green.
Yeah, so it's a calculation of what the it's called convective temperature, and what does the temperature need to be on the point here for a cloud to form. So this will be a cloud base as well. You might get lower cloud formation here, where that goes up and where it meets. There'll be a line it meets in. Again, it's in that article. I sort of explain it. It's called the I think it's the lower condensation level from memory.
Thanks.
Comes up. Okay, then the other one I've got is a more simple airgram that we've looked a lot at, and I think my question on this one is just simple: is this a sea breeze day? Yes or no, and why? So let's think about what's going on. These are the times across the top. This level down here is what you're getting in wind speed. Remember, small one is 5, big one is 10. Think about directions. And as you go up in the atmosphere, it's changing, and time of day is changing. What do we think? If this is Lymington, think about what direction you need and at what height you need it to potentially get a sea breeze going, and think about where the sea breeze direction is.
It's blowing quadrant 2, isn't it?
It's blowing what, sorry?
Isn't it coming from quadrant 2, isn't it?
No, not what time, sorry. If you think about what time, if you think about breakfast time, 8, 9 o'clock, what do we think it's doing at sort of gradient height? Sorry, I beg your pardon. If you think about it, about here, about 1,000 meters, what direction's that? Is it a northwesterly?
No.
No, it's more out of quadrant 3. So quadrant 3, I'll confuse myself. What are the quadrants we don't want? It's quadrant 3. Okay, and certainly as you go up, yeah, it's quadrant 3, more so here, yeah. And what about later on in the day? What can we see there? I mean, it's kind of west southwest, but fading, isn't it? It's not, for me, it's kind of too strong. Almost this breeze up here, it feels like it's just not quite. And the day I took it from, we didn't get a sea breeze. You had quite low cloud level here as well, which was capping everything. So it wasn't a sea breeze day. Okay, it looks marginal. I mean, on paper maybe, but I think just a little bit too strong at this height.
With the cloud coverage,
Anything, and that cloud's covering is going to stop the land heating fundamentally.
It's turned off the inland heating.
Yeah.
That with the southwesterly has turned it off.
Yeah, that's one of our factors, isn't it? Yeah. So strong strong sort of west southwest, and the cloud cover are, are two factors against us. And as I
Yeah.
say, when I recorded the numbers for this, it didn't kick. Okay, that is absolutely all I've got. I think I don't think I put anything on the end of that. No. So if there's any other questions or we're just all burnt out, I would understand.
I'll just remind us where that article is. Is it in the? It's on
Shall I show
the
you?
website.
Yeah,
Isn't it?
I'll take you to I'll take you there now. I'll take you there now. So ltsc.co.uk. Under dinghies and under weather and tides. Okay. And what I've done is I've put it all in the order you would need to do your brain casts and weather analysis. So if you remember the way we did it a few weeks ago, we looked at the surface pressure charts first. We looked at live weather reports. We looked at the webcam so we could see what was happening on the river. So we're looking there for mean direction and kind of haziness, cloud cover, whatever else. A couple of forecasting apps for you and the Portsmouth tide times. And then we worked down to weather resources. These are all the Simon Rowell videos, which are an absolute must. That air stability is my favorite one. That's really good, really good. You're laughing, Claire. You'll be all over it soon. Wind Strategy is the Bible, chapter 8. And here is one of the articles I've written, short-term weather forecasting for racing sailors. And there's an accompanying presentation with that, which I think is the one I did a few weeks ago. Here we are, it's this one. The Windy Advanced Usage is the one that will tell you how to install the sounding forecasts and how to use them. Okay, so it's this one. Windy Advanced Usage. So if I just click on that, I'll just show you what's in that very quickly. It's a PDF, and it just tells you how to install it and a few bits and pieces about it. And it talks about us thinking in 3 dimensions, which is that mixing, the vertical mixing. It talks about an airgram, which we've looked at already, and then these sounding forecasts. What do they actually mean? So again, you can see the winds down the side at what speed they are. So there's 2 different sounding forecasts they use. There's this one, which is what they call a Stuva diagram. It's all showing the same thing. It's just slanted 45 degrees over. And a skew T diagram, which is the other one I'm going to show you here. And it shows you how to pick off the stuff here as well. I hope. Yeah, I'll do an example there for you. That was exactly that question you asked me, I think, about the green line. Yeah. It goes through it and it gives you some more references as well, if you're really into that stuff. Okay, so that was on, sorry, my toolbar is blocked. Just hang on a minute. It's just by the, if I minimize that a bit, that might help. So just to go back where we found all that. So it was ltsc.co.uk. If you can remember, it's weather-tides or it's dinghies, weather and tides. And the advanced article, the article on the windy piece was there, windy advanced usage. Okay, and that presentation we gave the other night on the basic forecasting could be found here. I mean, I would almost give you the homework of watching that stability video. That is really good, really good. And that explains a lot about what we're trying to, some of the concepts we're talking about, which go behind